Okay, students, in the previous lecture 1 and lecture 2, we have discussed the basic properties of concrete like compressive strength, characteristics, compressive strength, tensile strength, flexural strength, as well as the stress strain graph for concrete in case of loading, in which we have studied two type of loading criteria. First one was when the loading was for a small duration of time, that happens in the concrete testing in laboratory. And then we have discussed how the stress strain graph will vary when the loading is a consistent loading and for a long duration of time. So today in lecture 3, let us see what will be the content. So here we will be going through the information regarding creep and shrinkage, and then this lecture will cover some information regarding the design methodology of concrete structures. Particularly, our focus is on reinforced cement concrete structures. So let us start it. Now we have gone through behavior of concrete under sustained loading for a longer duration. So in continuation to that, we have to understand that how concrete behave, or you can say concrete structure behave just as a beam or a slab, RCC structural elements. So behavior of the concrete when it is subjected to sustained loading for a longer duration of time, which happens in the practice. That means when you are going to construct a building or any RCC structure, and after getting the hardened, when concrete get hardened, and later on when that structure is in under use, that means during its service life, then it will be subjected to various types of loads for a longer duration of time. Some of the loads may be fixed load, which we generally call them as dead load, and as well as another type of loads are live loads. So what is basically creep in concrete? Now, as we have discussed in the previous lecture 1 and 2, that there is a gradual increase in strain with time, which you can just review from the stress strain graph. So when a concrete member is subjected to sustained loads beyond elastic strain, then what will happen? Then we can understand that another important aspect is creep strain. That means it is time dependent component of strain. Component of strain mean, if you just recall the stress strain graph, in that stress strain graph, initial part of the graph was a straight line type. That means it was a linear relation. So that linear relation gives us the information about the elastic behavior of the concrete, and the corresponding strain in the elastic range, that is known as elastic strain. And beyond that, behavior of the concrete will not be elastic, it will be inelastic type of behavior. So time dependent component of the strain, where we will be including the strain due to shrinkage as well as temperature stresses. So when you exclude the strain due to shrinkage and temperature stresses, then how that curve will be giving us the information, and that type of strain which is time dependent, that means it depends on the duration, that strain is known as creep strain. So it is very much clear that creep is a form of strain. Now from this picture, That is a sketch of the graph between the strain and the along x-axis we have taken time since application of the load. That when a load is applied, and we will be counting the time duration and how the concrete will behave and how strain will be seen in the concrete. So you can see here up to this particular limit, or you can say exactly up to this limit, here load is consistent and there is a strain, and the strain up to this limit is known as elastic strain because it is just a elastic part of the curve, a modified part of the curve. So this is the strain when load is within the elastic range. That type of strain is elastic strain. Now you can see here beyond this particular point, the graph is a just like a parabola, or you can say it is a particularly curve shape. So this curve shape you will see here beyond the elastic strain, which we have already mentioned here. Beyond the elastic strain, the strain which you observe, that is known as creep strain, and that is due to the creep behavior. Now after that, the graph will be reaching somewhere here, and now let us suppose the load is removed, that means unloading take place. Then the graph will be just a, you will see it is a dropout, and this type of graph, that means when you have just removed the load and there is unloading of the member, sudden drop you will observe, and this type of sudden drop we will say it is instantaneous recovery in the strain. And after that graph will be just as you can see here, the curve will be parabola and so on. So first of all we have gone through, that is first one is the elastic strain, then second one is the creep strain, and after unloading there is instantaneous recovery, and after this instantaneous recovery there is it will take some time to recover in the creep, so to reach its initial stage. So this is known as delayed creep recovery. That means it is not instantaneous recovery, so it will be taking some time. And after that you are observing here strain is almost remaining constant, so it means some creep strain just remained within the member which is termed as residual creep strain. So from this graph we are easily we can understand that how concrete behave under sustained loading with a longer duration. Now this creep strain is much larger than the elastic strain on loading. So this is the important point. Now elastic strain we have discussed that what is the meaning of elastic strain. Then creep strain we have gone through, elastic strain, creep strain. Then during unloading, instantaneous recovery, delayed creep recovery, and the residual creep strain. So all the information we have discussed. Now you can refer clause number 6.2.5 of IS 456 2000 to just get the information on what factors this creep of concrete depends. So I'm not going into more detail of the creep strain because it is expected that you have gone through it in detail in your earlier subject, that is concrete technology. So in currently I have just gone through this strain because many times when we are going to design a structure, then we will be just remembering or recalling the creep. So this is the reason, so that you people can understand what is the meaning of creep. So creep is basically a strain when the concrete member is subjected to sustained loading. That means loading remains sustained for a particular duration of time. So every structural member, every RCC structural member will be finding some strain, and that strain will remain within that member So that is basically residual creep strain which we are interested to understand. So on what factor the creep of concrete depends, you can just go through and read this clause number 6.2.5 of IS 456. And in that IS 456 you will be finding some table, and that table is under clause number 6.2.5.1, where it is clearly mentioned that in first column age of loading and creep coefficient, and you can observe here at 7-day creep coefficient is 2.2, at 20-day 1 year you will find that creep coefficient is on decreasing trend. Now what are the major effect of creep of concrete on RCC structure? That means how the creep of concrete will be influencing the design parameters of RCC structures. So very first point, very important point is, when you are going to design any RCC structure, then you will be first of all interested that how much deflection is will be occurring in the member due to the loading. So here the another effect of creep on concrete is it will increase the deflection of structural element such as beams and slab. So it will be increasing the deflection. It will increase the deflection in slender columns, as well as when we are talking about the pre-stressed type of concrete, which is not currently in our scope, but just for the purpose of knowing the information, that means there will be some loss of pre-stress in pre-stressed concrete due to the creeps. So that's why concrete is very important factor which we have to understand before going to design any RCC structure. Now another important aspect which we have to understand that is shrinkage in concrete. Now from the name itself is clear that shrink means there is some decrease in volume. So due to volume changes in concrete, now there may be some of the regions, maybe due to temperature rise, volume may change or volume may increase, decrease, etc. So shrinkage is the another factor which is very important. Shrinkage of concrete. Now let us understand, strain can also rise in concrete due to change in humidity and temperature of the surrounding with time. You are aware when a structural element is constructed in any type of building, RCC type of structure. So then what you can easily understand that with the change in duration as well as time, even with the change of the, or you can say during the day and night, you will be finding some temperature variation in day and night. So these type of humidity may change, temperature may change. So it is wrongly written here strain. It is basically strain. So strain can also arise in concrete due to change in humidity and temperature of the surrounding with time. Now concrete shrink in its hardened state due to evaporation of water due to any region, maybe because of change in ambient temperature. So what will happen? This will reduce the volume of concrete. When water is evaporated, then volume of concrete will reduce, and due to that some drying shrinkage will take place. And if restrained, if that means if that particular structural element is restrained to shrink, then what will happen? There will be cracks or deflection, and that type of cracks are known as shrinkage cracks. Earlier we have gone through creep, now it is shrinkage. So cracking due to shrinkage of concrete, they are known as shrinkage cracking. Drying shrinkage, as we have discussed, will lead to micro cracks. And when the concrete structure is prone to micro cracks or some cracks are emerging in the concrete member due to evaporation of water, it will definitely influence the strength of the concrete. That means it will weaken the concrete structure. Shrinkage also induces time-dependent strain. Let us go through the graph. Now you can see here along y-axis it is shrinkage strain, and along x-axis there is time duration. Now this time is calculated after 7 days of moist curing. So from this graph it is clearly visible as the time is increasing here, shrinkage strain is increasing. So here what we have written that shrinkage also induces time dependent. That means the shrinkage strain due to shrinkage also depends on the time, that means which we can see here, and after a particular duration you may find that the curve is getting almost flattened. Now here you can take the help of IS code 456 and clause number 6.2.4. So clause number 6.2.4 of IS 456 can be referred again for factors which creep of concrete depends, as already we have discussed. Now, effect of shrinkage of concrete on RCC, what will be the influence? So first of all, as we have discussed, if there is any type of shrinkage, then concrete will try to just get shrink, and if it is restricted to shrink, then stresses will develop, and it will increase the internal stresses, deflection as well as curvature. So it will be directly influencing the geometry of the structural element. Again, loss of pre-stress in pre-stress concrete structure will also be due to the shrinkage of the concrete. Now here, another point which we have to keep in mind, shrinkage can be minimized by reducing water cement ratio, by increasing the total aggregate content, and controlling the evaporation of water in the concrete. So here, later on you will be able to understand that how evaporation of water can be controlled. That's why we are using the curing of the concrete. So curing method is, if curing is done effectively, then you can just control or reduce the shrinkage effect on the concrete. Now, let us go through the reinforcing steel which we use in concrete, and that's why concrete members are given a new terminology, that is RCC, reinforced cement concrete. So as we have discussed in the earlier lectures, concrete is good in compression but very poor tensile strength. That means concrete will be behaving just or you can say it will be poor in taking the tensile stresses, and whenever there is a structural member which is made up of RCC, it will be subjected to flexural behavior, that means bending behavior. So when the loads and forces are acting on the member, it will be under flexure. So that means it will be under bending, and when a member is getting bent, then one part of the member will be under compression and other part will be under tension. But if that member is made up of concrete, as we know that concrete is weak in tension, then it will not be able to take care of all the tensile stresses, due to which cracks will observe in the member. And when cracks are there, definitely strength of the member will reduce, and your structure will not remain durable, and there are very significant chances of failure of the structure. Now what we do to enhance the tensile strength of concrete, that means tensile stresses carrying capacity of concrete. Now you can see here in the figure So first figure, figure A, what you can see, there is a beam member, simply spotted beam member, and it is suppose it is another member, then member will be under flexure and you will find some flexural cracks. So steel reinforcement, which are good in compressive and tensile stresses. We know that steel is very good in compression as well as tension to take care of the compressive and tensile stresses, because it has ductile nature. It possesses ductility. So steel reinforcement, that means steel bars are embedded in the concrete. In this figure you are able to see, suppose in first figure where only concrete member was there, and here what we have done, we have just embedded a steel bar. Now when load is coming on the beam, you will be able to see that only some hairline of cracks are there. And when load is further increased, then its behavior will change. Now you can see here, when you are increasing the load, and later on at some stage, you will be finding some minor cracks. And some minor cracks, that mean this steel member, due to its ductility, it will be starting yielding when load is beyond the yield point. So that means in figure A and figure C, if you compare, figure A will fail at the load which we are applying on the in the figure C. So that means what you can see here we have shown only a single load, here we have shown three number of loads. So you can easily compare figure A and figure C. That means in purely concrete structure, it can take a very small amount of load, but same beam, when a reinforcement is provided, now it becomes a RCC beam, then its load carrying capacity is significantly improved. Now steel bars to be used in concrete should form a good bond with concrete, otherwise it is useless. If it is not forming a good bond, then steel will automatically get ejected from the member. So it is very important to assure that there is a good bond between steel bar and concrete, for which they should be very much clean and free from loose mill scale, dust, loose rust, and any oily material. So that means steel bar should be free from any type of rusting material, so that the steel bar can effectively get bonded with the concrete. And after that, steel bar as well as a concrete, they will act as a composite material, not as individual material. Suitable treatment may be adopted to get the reinforcement clean. That means you can use any type of just like sandpaper you can use, and if there is any scales or any dust is seen on the steel, or you can just by using the sandpaper you can clean the reinforcement before embedding it in the concrete. Now few points which are very important: physical and mechanical property of these different type of bars which we can use. First of all, we can use mild steel and medium tensile steel bar, which is termed as MS bar, which conform to IS 432 Part 1 1982. So you can use mild steel bars. You can use high yield strength deformed bar, commonly known as HYST bars, which are conforming to the guidelines given in IS 1786. Then hard drawn steel wire fabric conforming to IS 1566. So there are various type of steel bars available, and which are conforming to different type of codes. So you can use these type of steel bars in concrete. Another type of structure steel conforming to grade A of 2062. So any type of steel as per your requirement you can use as a reinforcing material. For more detail, you can refer clause number 5.6 of IS 456, and you can refer special publication SP 34, where table 1.1 give all the related and important information regarding the steel bar, which you can use as a reinforcing material in RCC structures. Now, let us have some brief information regarding the design of RCC structure. When you are going to design any RCC structural element, just like RCC beam, RCC slab, RCC column, footing, etc. So first of all, we must be clear that what are the objectives of design. If you are clear in the objectives of the design, then you can design accordingly so that all the objectives can be met out. Now, what is the main objective? Main objective of any structural designer is to produce ductile behavior in RCC member, such that it is available to safeguard human life. Because if the material is brittle, suppose you have designed a member which is brittle, so when load it is subjected to service load, then at a particular point it will collapse. So brittle material will collapse and the whole building can collapse. But if the member is truly ductile, then what will happen? It will be, when it's subjected to loading, what will happen? It will start bending. And when there is a bending, that means before failure of any structural component, it will give us a lot of burning. That means just on viewing that structure, you are able to understand that, and later on it will be going to fail. So failure can be avoided. So that means when you are going to design a structure, its behavior should be ductile behavior, which will give sufficient warning sign. Now, structural design must satisfy some basic requirement. So very first is stability. Your structure must be stable. Stable means any type of overturning, sliding or buckling of the structure or any part of it under the action of load should be prevented. Otherwise, its stability will lose and the structure will not remain stable and a failure can occur. Second important aspect is strength of the member. So structural components should be of sufficient strength so that they can resist the various type of loads, forces or movements which are going to happen due to the service loads when it is under the utilization. Third, very important, is serviceability. Serviceability means when the structure is exposed to service load. And so we are saying it structure should perform satisfactorily for the intended purpose, for the purpose for which purpose it is built. So it should fulfill all the purposes. Its performance should be very much satisfactorily under service load condition. That means it should have adequate stiffness, which is required. And if there is any type of deflection, crack width, permeability, etc., then these type of happenings, that means deflection, crack width and permeability, it must be within permissible limits, and these permissible limits are clearly mentioned in various Indian standard codes, just as IS 456. Now, what are the design methods which we can use, or design methods which are adopted and are currently in practice? So first of all, our guidelines will be available in the code IS 456. So what code is saying? You can use the limit state design method. That means limit state method of design of RCC structures as per IS 456 recommendations. Secondly, you can also use the earlier method of design, that is working stress method, but code is saying that wherever limit state method cannot be adopted conveniently, you can use working stress method. Otherwise, currently or in these days, we have to adopt this limit state method of design. In the later lectures, we will be able to understand that what is the difference between working stress method and the limit state method, and which one is better, and if any one is better, why it is better. Now, some basic codes which you have to be kept with you when you are going to design. So, some of the important codes, first of all, we know that it is IS 456 2000 version, plain and reinforced concrete code of practice. Now, how to estimate the various type of loads which can occur? That means how to assume the loads. So some guidelines are given. There is a series of codes IS 875. In part 1, information regarding the dead loads is given. In part 2, imposed or live load information is available. Part 3 is devoted to wind loads wherever structures are subjected to winds of high velocity. Part 4 is devoted to snow loads. Part 5, special loads and load combinations. Later on you will be able to understand in all the details. And whenever you have to design a structure so that it should be earthquake resistant, then you have to refer the guidelines given in IS 1893 2002. Thank you.